In example 4, we have suppose the amount of oil pumped from one of the canyon wells decreases at a continuous rate of 10% per year. When will the oil well's output fall to 1/5 its present level? So this is kind of like that half-life. So when I start solving for K, I start with the 1/5 equals. So I'm going to start with 1/5 equals E, and they actually hid K in here for us. So it says at a continuous rate of 10% per year. That is K, that's a rate, so negative 0.1 T, and this is all we have to solve. So we're going to clear the E with ln. So I'm going to say ln. I like to change my inside by ln into a decimal. I don't really like the fraction, so I'm going to say 0.2 equals negative 0.1 t. And so to solve then for t, we're going to say t is equal to ln 0.2 divided by negative 0.1. You'll put that in the calculator, and you should get that t is about 16.094 years. Not so bad as long as we remember some of these keywords and how to identify an exponential relationship from pre-calc. Example 5, suppose the population of fruit flies grows in proportion, so that's our key here, that it's exponential, to the number of fruit flies in the population. If there were 100 fruit flies after the second day, so I'm going to make myself a little table, so day 2 is 100, and 500 after day 4, so 3 we don't know what's there, but day 4 500, how many fruit flies were in the original population? So this is a calculator problem. There is a really, really easy way to get this. Just kind of reason through it because this is very easy right here. So from 2 to 4, that multiplied by 5. But the key is knowing that this is exponential. So if we skip 1 and go back to 0, what do you expect to be there? All right, hopefully you took a guess and said 20. 20 is what we expect to be there. So let's actually solve this problem to see if we get 20. So we're going to start with an x and y. So from our table, I'm going to pretend like this is my start, and then this is the one that I'm plugging in. So what I'm going to write is 500 equals 100, the one I know, E, K, and this time it's going to be t minus 2, because that's not like time equals 0. So again, I said t minus 2 because it's starting on day 2, so I need to then plug in 4 for time, so 4 minus 2 is just 2. And I'm going to solve this for k. So we're going to divide that off. I'm going to get 5 equals e to the 2k. We're going to ln both sides. So ln 5 equals 2k. So ln 5 divided by 2 equals k. So we'll solve for k, and then we'll see if we can find that initial starting value. So going back to our initial problem, I have y equals, we said 100. E, it's going to be, we know k now, ln 5 divided by 2. And we said that that time was going to be t minus 2. And so now what we're going to do is we're going to plug in 0 to see at time 0 what we got there. So I'm going to say y equals 100 e ln 5 over 2. Plugging in 0, we're going to have a negative 2 right there, so we're going to put that in the calculator. And you should get 20, so our guess was correct.